So we know which of the following is the correct interpretation of the p-value. So all we're doing is we're counting how many different samples that we randomly generated, assuming the null hypothesis is true, would give us what we saw from our particular sample, or something in this case smaller than it. We saw that happen 0% of the time. So it's telling us the probability of observing a difference in sample proportions as large as the one in the sample, or even larger, if physicians are equally likely to have a heart attack, whether they take an aspirin or not. So the correct answer would be D, because we're looking at which part says the null hypothesis is true. So there's basically a 0% chance we would see a difference as big as that one or bigger just from random chance. 19 says, what decision do you make regarding the hypothesis? So you want to remember that once we have our p-value, we want to use it to determine whether or not we want to reject or fail to reject the null hypothesis. Well, since our p-value is really small, we have really strong evidence against the null hypothesis, so we want to reject it. Small p-value indicates that we reject the null. 20 says, what is the conclusion of the hypothesis test? So that's our generic conclusion, that we're just going to reject the null hypothesis. But what does it mean to reject the null hypothesis? What are we actually concluding about aspirins and placebos? So we can say that there is strong evidence, because we rejected the null hypothesis, that whatever the alternative hypothesis is saying is that aspirin, physicians taking the aspirin are less likely to have a heart attack than those who are on the placebo. So our correct answer would be A. Then 21 says, if you had used a 1% significance level instead of a 5%, how would the p-value been affected? Well, we didn't really use the significance level at all until we got to make the chance to make our decision. So we only compare the p-value to the significance level, and that's the only time it comes into play. So it doesn't matter what we change our significance level to, the p-value is going to stay the same. It's just how often our particular sample occurred out of the 200 randomization samples that we created.